Hello everyone. Let us start our next topic, that is rules of inference, or even we can call it as an inference rule. So in this we are considering compound propositions P1, P2, P3 and so on up to Pn, and the resultant will be uh, proposition, and these P1, P2 so on up to Pn are called as the premises. Let me read out the what is written over here. Consider a set of propositions. So these are the set of proposition and a proposition q. So our resultant is also a q. Then a compound proposition of the form, this one is called as a argument. So whatever we derive, that is called as a argument. Here p1, p2 so on up to pn are called as a premises, and q is our conclusion. So we can even write this in this form, that is p1, p2. But in this, what to remember here is p1, p2, p3. There is an AND operation AND operation among p1, p2, p3, so on up to pn. These are the compound propositions, and not an OR operation. That is the most important thing to remember over here. This argument is valid if each of p1 to pn are true and q is also true. If p1 to pn is true, then only the q will be true. And coming to the next slide, we have certain rules of inferences. First is conjunctive simplification. In the conjunctive simplification, conjunction we have studied in the laws of logic. So that is an AND operation. So here, for any two propositions p and q, if p and q is true, if this is true, if the p and q is true, then p is true. If the first two, that is p and q is true, then p will be true. So the second one, rule of disjunctive amplification. Rule of disjunctive amplification says that p implies, that is p or q. So p or q will be p itself. Okay. So whenever while simplification, if at all we come across such a concept or such a case, that is p or q, we can straightforwardly write it as a p itself. That is or operation will give us a p itself. And rule of syllogism. Rule of syllogism is, here we have a conditional operation p conditional q and q conditional r, that implies p conditional r. So it can be written in this form itself: p conditional q, q conditional r, and p conditional r. Modus ponens. So it is even called as a detachment. P and p conditional q implies is equivalent to q. So p and whatever we write in this form, that is an AND operation itself. P and p conditional q, it is q itself. It is called as a modus ponens. Yes. Next, modus tollens. P conditional q and inverse of q, that is equivalent to inverse of p. So p conditional q and inverse q is equivalent to inverse of p. If p conditional q is true and q is false, then p will be false. So among this, whenever we have a AND operation, both should be true. If any one among this is false, then it will be false itself. Rule of disjunctive syllogism. It says that p or q and inverse of p. So it is q itself. So the resultant will be q. P or q, inverse of and inverse of p is its resultant will be q itself. Rule of contradiction. Rule of contradiction. Inverse of p conditional f naught. F naught is nothing but contradiction, is p, and negation of p and conditional f naught is implies, that is q. So we'll see an examples on this inference rules. First one, if interest rate falls, then stock market will rise. The stock market will not rise, therefore the interest rate will not fall. So first we need to assign the propositions P and Q for these statements, and then only we have to we can derive whether that statement is a whether the compound statement is a valid or invalid. So here we have taken a propositions for P and Q. P is assigned for interest rate falls and Q stock market will rise. So stock market will rise, and now according to our statement, therefore given argument reads the given argument, if interest rate falls, P is our interest rate falls, conditional, stock market will rise. Stock market will rise is a Q. Second one, the stock market will not rise. Negation of Q. So therefore, here we have written it as a three dots. Therefore, interest rate will not rise, will not fall. Interest rate will not fall. Here will fall, it is interest rate. Here interest rate will not fall means here we have to write a negation. Negation of P. So where we come across such a situation is, if you go back and see the in our inference rules, so it is modus tollens. The same exactly the uh, same propositions, and there is a conditional between P and Q, and there is an AND operation between P, the conditional Q, and in inverse of negation of Q. So the resultant is negation of P. So if you see this, it is a modus tollens rule. So this is an invalid argument. So there is a one more example. If I study, then I do not fail in the examination. If I do not fail in the examination, my father gives a two-wheeler to me. Therefore, if I study, then my father gives a two-wheeler to me. So here there are three statements. Since there are three statements, we have three propositions. Three propositions said, that is P, Q, and R. First one, I study. I study P is assigned to P. Q, I do not fail in the examination. I do not fail in the examination is assigned to Q. My father gives a two-wheeler to me. So the given proposition is in the form, if I study. If I study, then I do not fail in the examination. Directly there is a if then statement it is. Next, if I do not fail in the examination, my father gives a two-wheeler to me. So here Q conditional R. Therefore P conditional R. If I study, my father gives a two-wheeler to me. That's what is there in the previous this one. Yes, I study, then my father gives a two-wheeler to me. So this is, if at all you come across P conditional R, that should be definitely a syllogism itself, as we saw in the rule section. This is the rule section. Here you can see that particular rule. Coming to the next one, if Ravi goes out with friends, he will not study. If Ravi does not study, his father becomes angry. His father is not angry. Therefore, Ravi has not gone out with friends. So first, assigning the statements to the respective propositions P, Q, and R. First, for P, Ravi goes out with friends. Okay, and that is for P. For Q, Ravi does not uh, study, and R, his father gets angry. So according to our proposition, according to the statement, if Ravi goes out with friends, he will not study. Ravi goes out with friends. P conditional Q. Ravi, if Ravi goes out with friends, he will not study. He do not study and he will not study, both means same. So P conditional Q. Next, Q conditional R. Q conditional R. Ravi does not study. Not study. his father becomes angry. His father becomes angry. So it is Q conditional R. His father becomes angry here it is. So that's why in the given statement his father is not angry. Negation of R here it will be. Negation of R. So the resultant will be, if at all we come across such a situation, then and the finally Ravi has not gone out with friends. Ravi has not gone out with friends means here negation of P. Negation of P. So negation of P, P conditional Q, Q conditional R. If you simplify this, then you will be getting P conditional R by P conditional R by rules of syllogism. Next, if at all you consider this one and P conditional R and negation of R. So if you look this one uh, and the resultant is negation of P, this in this view modest tolerance rule, this is a valid statement. If you see the modest tolerance, it will be the same, exactly same. So here modest tolerance rule is applied over here. What to be stressed here is P conditional Q, Q conditional R. So if at all we see the rules of syllogism, we can easily write P conditional R. So that is applied over here. Negation of R as it is. So since we have since negation of P, so it our the statement we can consider it as a modest tolerance. Okay. Uh, yes, we'll see some of these examples also, and the same concept. One more example is given, and just go through these examples, and we shall continue with such a similar concepts in the next video. Okay. So all these inference rules, the statements will be given. When the statements will be given, we have to assign it to the propositions. We have to form a compound proposition, and once we form a compound proposition, then we have to apply which rule is applied, which rule will be applied. Once if a particular rule is applied, then we can say that it's a valid statement. Otherwise, it is not a valid statement. Thank you.